Hello students, myself Saurabh Maheshwari, Assistant Professor Computer Engineering and Women Engineering College Ajmer, and we were doing subtraction using r minus 1's complement, and in this lecture we will complete subtraction using r's complement. Okay, so in the previous video you have seen that these are the steps that were followed to perform subtraction using r minus 1's complement. So the difference between r and r minus 1's complement is not a great difference. The only thing is that while performing subtraction using r's complement, you have to take r's complement of the negative number, and while performing subtraction using r minus 1 complement, we have to take r minus 1 complement of the negative number. Okay, so we will start the process with an example only. So if I will do example in decimal number system because that would be very easy for you to understand. And here I will write down the steps for the processing of subtraction. Okay, so first let me take an example, that is 72 in decimal. If I want to subtract 48 from this. Okay, so this is an easy subtraction. Okay, we started r minus 1 complement method also from a question like this. Okay, so what happens here, we want to convert this subtraction operation into an addition operation. So what we do, we make this 48 as a negative number, and this minuend is kept as same. Okay, so our first step is to convert. Okay, convert subtrahend. Okay, subtrahend to a negative number. Okay, and the subtraction operation subtraction operation is converted to addition operation. Okay, by this method we were able to convert this subtraction operation to this addition operation. Okay, so now what would be our next step? You can remember from the previous from the previous slide that the step number 2 was for estimating r minus 1's complement, but now here we are doing with r's complement. So perform r's complement of minuend, sorry, of subtract. Right, we have to perform. Okay, so we have to perform r's complement of subtract. Okay, so what is r over here? R is 10 here, so it would be 10's complement. And do you remember the method how to convert? The method was simple, that except lsb, you subtract all the digits from r minus 1 and subtract the lsb with from r. Okay, so r is 10, so this would be 10 minus 8 is 2, and 9 minus 4 is 5, minus okay, 52 in decimal is 10's complement of minus 48. Okay, now third, perform r's complement of subtrahend. Okay, the thing that is important here is this. Okay, in the previous method we did r minus 1 complement here. Okay, and here we are doing r's complement of subtrahend. Okay, to make it positive representation. Okay, now what would be the next step? The next step from the r minus 1 complement also, what we did, we simply added this addition. Okay, so we have 72 in decimal to be added with 52 in decimal. Okay, we have to perform this addition. Okay, so I will do this addition. Okay, so 2 and 2 is 4 and 7 5 is 12. Okay, 2 and 1 goes to the carry. Okay, 1 goes to the carry and carry comes here. Okay, so carry comes here. Okay, so what we will write the third step: perform addition of minuend and r's complement of subtract. Okay, so what is r's complement of subtrahend is 52 and minuend is 72. We performed their addition and the result was 124 in decimal, where 1 is the carry. Okay, so now again the last step is very important: if carry is generated. If carry is generated. Okay, both of the methods have same steps as 1, 2 and 3. The only difference is r's complement. Okay, now the difference, another difference that comes here is at the fourth step. Okay, if carry is generated, what we did there in the r minus 1 complement, we added this carry. Okay, you can see here that in r minus 1's complement method, in r minus 1 complement method, you added this carry. Okay, you added this carry to the lsp. Okay, now here if carry is generated, then discard it. Okay, here you have to discard it. Okay, so this one is discarded. Okay, and remaining digits is result of subtraction. Fine. So remaining digit is 24. So result of subtraction is 24 of this subtraction. You can calculate it very easily. It is the right answer, and this you can in this way you can perform this particular subtraction using r's complement. Okay, I will take one more example from decimal domain only. Okay, then we will proceed to other number systems, right? Okay, so let me take one more example. If suppose I take 64 in decimal and I take 92 in decimal. Okay, and I want to estimate its answer. Okay, it is very clear that the answer would be 28, but it would be a negative. Okay, negative answer, right? So here you can observe one thing, that the answer is negative. Okay, so answer is negative. Now we will see that when the answer is negative in r minus 1 complement method, you saw that carry does not get generated. Okay, so here we will also come here we will also come on the same condition, as if carry is not generated. Okay, generated. So let us prove that carry is not generated. Okay. Okay. So before that, let us perform this step by step. 64 in decimal. What would be the first step? It is simply to convert this subtraction operation to plus operation and convert this number into a negative number. Then you have to take this tens complement. Tens complement is simply you have to subtract LSB by R and remaining all bits by r minus 1. Okay, so that would be 8 and that would be 0. 0, 8 in decimal is the 0, 8 in decimal is the r's complement, or I can say tens complement of minus 92. Okay, so the step number 3, this was step number 2 to perform tens complement. Now step number 3 is to add this particular minuend, okay, to the r's complement. Okay, so r's complement of the number. Okay, so I have to add this and this. Okay, so the result is nothing but 72. Okay, 64 and 8 is simply 72, and you can see that no carry generated. Okay, so no carry generated. It, what does it mean? It means the result is negative. Okay, it has two interpretations, that result is negative and the result that you have, the result of subtraction is negative. Okay, result of is negative for subtraction. Okay, right. And uh, result of addition that we have performed right now is 10 is nothing but r complement of negative result. Okay, so it means the result that you have got from the subtraction from the addition, and there is as no carry being generated, so it means you have to take another r's complement here to convert it into a negative number, so that you can get the final answer from it. Okay, so how we are going to convert 9 and 10 and 72? This gives you 8 and this gives you 2. Okay, so 28 in negative. Okay, 28 in negative. 28 in negative. Fine, 28 in negative is what the result of this subtraction. Okay, let us do more example in other number systems. Okay, let me take one more example. Suppose I go for octal system. Okay, for octal system, I will take an example like 743. Okay, 743 in octal to be subtracted from. Suppose I want to subtract it from 772. Okay, now I want to subtract these two numbers from each other. As I can see that the subtrahend is larger than the minuend, so it would be obvious to say that the result would be a negative number. Okay, so for this negative number, what we have to check that there would be no carry generated when we will perform addition. Okay, so let us solve it step by step. First step is say 7438 converted into positive operation, and the number is in negative form. Okay, for negative form you have to take 8's complement. Okay, for 8's complement, what is the process? You subtract the LSB from R and remaining from R minus 1. Okay, so 8 minus 2 is 6, 7 minus 7 is 0, 7 minus 7 is 0. So 6 in octal is the 8's complement of minus 772. Okay, so what we have to do, this was our second step, and this is our third step. 743 in octal to be added with 6 in octal. Okay, so this gives you 743, and you have to add 006 here. So 6 and 3 is 9, and how you write 9? 1 here and 1 to the carry. 4 and 1 5, and it's 7. Okay, 751 in octal is the result of addition, and you can see that no carry generated. Okay, so no carry generated, it means the result that you have received 7518 is the you have received r's complement representation. It means 8's complement representation of the negative result that we are expecting. Okay, so to get the negative result, we have to again take a 8's complement of this answer, because carry has not been generated. Okay, so we will apply same method 751, and that will be 778, that is 7, that is 2, and that is 0. So 0278 and in negative. Okay, so the result of this subtraction is minus 27 in octal. Okay, so this is how you are going to solve this in octal. Right, I will take one more example. Let us do it in binary also. Okay, so 101101, and I want to subtract it from 011101. Okay, so 3 in 3, 6 digit, 6 digit. Okay, so that I want to subtract from each other. Okay, so I will start with first step. This number remains same, but this number becomes negative. Okay, 0 1 1 and 1 0 1. Okay, now this negative number has to be represented into its complement form, that is 2's complement form. And do you remember how we convert, how we take 2's complement? Is first we reverse all the bits. Okay, we reverse all the bits and then add 1 to the LSB. So that is 1 1 triple 0 and 1. So this is the 2's complement of this particular negative number. Okay, now the step 2 is completed to take 2's complement. Now step 3 would be to add upon these two numbers. Okay, I am taking 1 0 1 1 0 1, and if I add it to the number, that is 1 0 0 and one more 0 and double 1. Okay, so this is the number that I want to add. Okay, 1 1 is 0, 1 to the carry, 1 1 is 0, 1 to the carry, 1 1 is 0, 1 to the carry, 1 1 0, 1 to the carry, 1 1 0 and 1 to the carry. Okay, so this carry is generated. Okay, so carry is generated, carry is generated, right? So if carry is generated, what you have to do? Discard it. Okay, so we have to discard it. Okay, so after discarding it, we get this result 0 1 0 0 0 0. Okay, this binary result, we get this binary result, and this is the result of this particular subtraction. Okay, so let us do one more example. So this was one more example and this was one more example. Let us do one more example for hexadecimal, let us say. Okay, so hexadecimal, I want to perform, suppose this 5A923. Okay, and in hexadecimal, and I want to subtract A32 BC 3 and 2 5. Okay, this I want to subtract from each other. Okay, so the steps are same. 5A923, this is the hexadecimal minuend. Now this negative operation is converted into plus, and this number is changed to a negative number. Okay, A35BC and hexadecimal. Fine. So for converting this negative number to a positive representation, you have to take 16's complement, r's complement. We are doing with r's complement method. So what is r here? 16's complement. To get the 16's complement, the method is very simple. You subtract LSB from 16 and all others from r minus 1. That is 15, 15, 15. Okay, A, 3, 5, B and C. Okay, so this was the number, and 16 minus C. C is 12, right? So that gives you 4. Okay, 15 minus B. B is 11, so that gives you 4. And 15 minus 5, that gives you A. Okay, 15 minus 3 is 12. 12 is 10, 11, 12. 12 is C. Okay, now 15 minus a, that is 5. Okay, so this 5CA44 in hexadecimal is 16's complement of this negative number. It is a positive representation of this negative number. So this was our step number 2. Now we will perform step number 3. In this step, we will add 5A923 in hexadecimal with 5CA44. Okay, so these two we will add. 4 and 3 is 7. Okay, 4 and 2 is 6. A is 10 and 9 is 9. Okay, 10 and 9 is 19. And how you are going to write 19 in hexadecimal? That is 16 and 3. Okay, so 3 is here and 16, that is 1 is here. So 1 3 16 in decimal, sorry, 19 in decimal is written as 1 3 in hexadecimal, right? 19 in decimal is written as 16 in 13 in hexadecimal. Okay, so A and C, A is 10, C is 12, right? And one more, so it is 22 plus 1 23. And how you are going to write 23? 23 in decimal is equivalent to 16, and how much there left? The 7 is left. So 17 is 17 in hexadecimal. So 7 would be here and 1 will go here. 5, 5, 10 and 1, 11. 11 you write as B. Okay. So there is no carry generated. You can see that no carry generated, right? So if no carry is generated, what does it mean? That the result of this subtraction would be a negative number, and the result that you have found due to addition is a R's complement representation of this negative result. Okay, so to get that negative result, you have to take again R's complement, that is 16's complement. You have to find out for this particular number, and how you are going to do that. B7367. So this is our number, and how you perform? You subtract LSB from R and remaining all other bits from R minus 1. You can get these methods, right? For individual methods, I have put up previous videos for that. You can take reference from that, how to calculate R's complement and R minus 1's complement. The videos are found can be found on my channel and in the same playlist, right? So 16 minus 7 is 9. Okay, 15 minus 6 is 11, and 11 is simply B. Okay, sorry. 15 minus 6 is 9, right? 15 minus 6 is 9. Okay, 15 minus 3 is 12. 12 is C. 15 minus 7 is 8. Okay, and 15 minus B is 4. Okay, so 4, 8, C, 9, 9 in hexadecimal as a negative number is our answer and result for the particular subtraction. Okay, I have given you the same practice question that that we did in the R minus 1's complement. So it's the same practice question, but this time these practice questions you have to perform using R minus 1's complement, sorry, R's complement. R minus 1's complement, we have performed the same question. Now these same questions you have to perform with R's complement method also, and also reverse check. Okay, also reverse check all these questions to verify your answer. Okay, so overall this is our R's complement method for subtraction. And one more topic we will do in this arithmetic of number system, that is that is to conversion of the floating point numbers. Then we will complete this number system chapter for our purpose, and all the videos are available in the playlist. You can see and complete all the practice questions that will be taken in the assignment. Okay, thank you. Goodbye.